Ava and Kayleen, why don't you go ahead?
Okay, cool. This is it's like really, all of this is really like not set in stone or anything, so just keep that in mind as I go through. So the first slide is a list of like assumptions, because we were kind of shooting blind, we didn't know what we were designing. So we made like 3 major assumptions that were should probably work with you guys, but if you want to change them, that's totally fine. The first one is that we want to be able to work with whatever we build, and we want to use it during competition season, or we want to be able to build something that gives us knowledge that helps us during competition season. The second one was that we wanted to build an attachment arm, that not a chassis, not like the main robot, but just an attachment arm that could be used for a specific purpose. And then we decided that the purpose that we were going to use is to pick up like wiffle balls, like Aiko was saying. So those are the 3. And then we have 3 designs kind of that we came up with, but they're not set in stone designs. They're kind of just different ways that we would attack the problem. So if you want to go to the next slide, I could.
Does anyone have questions about those assumptions?
Oh, yeah, too. Yeah, that's too.
No, you can continue on the next page.
Here, I'll go back. Is everyone good? Everyone has everyone.
Okay. So this one it'd be an active intake, so it'd be less, it'd be harder to control in the sense that it would require control, but it'd allow for more for faster pickup and for more accurate pickup. So it'd be basically several like compliant wheels, which are rubber wheels that are like squishy, that would be attached to the axle in front. This would power the motor for the intake, so they would spin with the motor. I think she was thinking of using a gear system to do that, but she didn't have time to cat it. So basically they would just move the ball into like the chassis or wherever the containment facility was. So yeah, if anybody has any questions on that one.
What's the black structure in the end? I don't know how to.
That's the motor that'll make the axle spin.
Yeah.
Oh.
I think another cool part about this design is a lot of the times during like FTC games, you're only allowed to pick up like 2 balls at a time, or like 1 sky stone at a time. So if we were put in a situation where the game would require us to have more specificity in the amount of balls that we're taking in, it wouldn't accidentally take in too much.
Yeah, and another added bonus of this one is that we could, if you reverse the direction of the motors, it could be used as like an outtake mechanism as well, which is good because it's like simpler to build.
How come we didn't use this year?
Yeah, I don't know, but so this is like the step up, and then Kayleen's is.
And then it's kind of chaotic. I'm sorry. So basically, if you look on a sketch, I don't know if you, because mine has like the. Okay, you can move it. So basically, it's. Do you know the car wash, the car washes where you like drive through and they have like big like spinning things?
I think this is great.
Yeah, that's why I use the pictures on the bottom where they have the little brushes. So the intake would be connected to like a long tube, so the ball would enter from the person rolling the intake over some balls, and the bristles or whatever it would be spinning would push the balls into the tube. And this could either be done by the V, which I have shown right there. I'm not sure how to explain it, but it'll be like the size of the ball, and so it'll like just kind of suck it in. Or we could do it like where it's horizontal instead of vertical, and then the 2 bristles would be like this, and it'll just like kind of roll over the ball, and then it'll suck it in as well. And it'll end up into the tube, where it could be either ended up out, like come out the other end, so we can just take it out.
Yay! Does anyone have any questions about that one?
I have a general question. I still want to know that how can we test it without a drivetrain? Because when you want to pick up the ball on the ground, you have a stable mechanism on the like chassis or something else.
So there's a couple ways. If we just wanted to test like whether or not it can pick up a ball, we could just hold it and see if it can do that like independently. Or we also have like I don't know if you have like still have a working robot from last year, or any sort of like train or chassis that you have still,
Oh, yeah.
but we can attach that to that.
I think if you just wanted to hold it or something else, I prefer the second one, because the second one you can hold the mechanism towards any balls you want. And the third one, this one might be widely used in competition, but you cannot test this functionality without stabilizing it.
Yeah, those are really good.
Yeah.
Flora, can you
next
move
page?
on?
Thank you.
Slide. Can you move on the slide to the next page?
This one is not controlled by
Hello, Helen.
and I can describe the next page. And it is a FTC robot, and it was built by our teacher. And what I want to say is when we build the circuit, yes, and is this circuit, we need many circuits. So we need to give every circuit a label for them. And so when we connect it to the motor, and we can know which one should connect with which motor. So my suggestion is when we connect the circuits and put the circuits on the robot, we should label them. Yes.
Yeah, I think those are all really great ideas. I completely support all of them. You could kind of see our previous robot that we have had like exactly what you're talking about, like with wire control. We tried to label all of our wires.
I guess that the last robot she mentioned was the robot for other schools, because we have a few teams here and other teams from other schools, and they made this robot for this year. Yeah, and we haven't made one for our team this year, so I guess we can, through this change, we can test what mechanism can grab the cube better.
Yeah, so I'm thinking that if are you only using the a shaft to like get the balls in? Because do you think you need to like add more things onto it so like you can make sure that you actually get them in, like make sure they don't like slide to other places?
Oh yeah, that's a good idea. So do you mean like making like a stop here, or like kind of like a closing, open and close?
Yeah,
Yeah,
like you can make an angle to it so you make sure when you like get them in you don't like accidentally drop them out.
sorry, I was writing what you were saying down. That's why I wasn't responding. But yeah, that's a really good idea. Just basically having some way of like closing it. That way it doesn't like come back out.
Also, I like that idea for when we're picking it up, so we don't accidentally push the things away while we're trying to pick it up. Is a good application too.
Does anyone else have any other ideas of how we can make this design better before we, fully CAD it? Other than, adding it and making it functioning with the gears.
Actually, uh, was that the core hex motor?
Ava?
Yeah.
So how do you use this axis to do like conveying the ball or do something else?
I'm pretty sure she also had like the idea to just like push it in with some kind of spinning thing.
Keelan, are you muted? Wait, maybe that was mine. Or maybe everyone's muted for me. Sorry.
Did you hear me?
Do you mind repeating just for me? Probably other people heard you, but my computer cut out.
Oh yeah, so Sebastian mentioned that it was gonna be some sort of spinning thing, and then Camilla agreed. So I'm assuming that she's gonna do some spinning thing as well.
Yeah. And for the gears specifically, we were gonna use a similar mechanism to the drive chain that we use. So like using a chain to help do kind of like a pulley system sort of thing, connecting it to the spinning wheels. But I think the specificities of trying to do gear stuff is hard if you don't know the exact gears we're using, and because we haven't CAD'd it out yet. With the specific gears, we haven't figured out the exact like ratio that we're going to use for the exact.
This is what she's talking about when she says like drive train with the chains. Like these chains are connected to the motor, which allowed us to, move the wheels. Not directly. So basically, what she's saying is that our motors were connected to a smaller gear, and then because we connected that gear to a larger wheel, it helped the robot somehow. I believe that it made it more powerful, like added torque to it, but
it also made it a lot faster because the chains are smoother than the actual gears themselves when you're trying to attach them to wheels. So it's just and that's also good for like trying to transfer spin to different areas. So because the intake arm that we're using is so most of the wheels are so far away from the actual motor itself, that's why chains will be helpful.
Do you want to make some outer wheels that can collect the ball first, then get into the mechanism?
Oh, that's smart. So are you saying here?